Okay, thanks for joining us for chapter 3.2, which is graphs of functions. So we're going to look at understanding odd and even functions and graph piecewise functions. We're also going to look at the average rate of change in these notes. So need to know functions. So on the website, I have a parent function handout, or you can get one from me. And it just goes through some common parent functions. Okay, so there are a couple that we're not going to want to really look at for now. So we can mark out the greatest integer function. We would go ahead and mark out the rational. We'll look at that one later on. And then the sine, cosine, and tangent, we're going to ignore those for a little bit. Okay, so we're going to look at linear. Absolute value will be an important one we look at. Quadratic we'll look at quite a bit. Cubic, square root, third root not so much, exponential and logarithmic. And we'll hit on reciprocal a lot more later. So keep this handy. At any point, I should say, what's the cubic function look like? And you should be able to tell me or sketch out this curve for it. Or what's the logarithmic parent function? You should be able to sketch out that curve as well. Okay, so keep that handy. So those are the need to know parent functions. So make sure you're studying those. Okay, so how to determine if a function is odd, even, or neither. So odd, this goes back to our symmetry lesson, x-axis, y-axis, or origin symmetry. So here, if I take f of negative x, so I'm taking negative x and I'm plugging it back into the f function. After I work that out, if I get the opposite of what I started with, so negative f of x, that would tell me it's an odd function. Okay. If I plug in negative x to the function and I get back the original function, it's an even. If neither one of these, if I don't get the same or if I don't get everything opposite, it's neither odd or even. Okay, so make sure we've got these formulas here down. So determine if odd, even, or neither. Okay, so we're going to say f of negative x equals, and we'll just put negative x here for x. So I have negative x squared minus 3. Well, negative x squared, that would be x squared minus 3. So x squared minus 3 is the same as x squared minus 3. So that equaled your f of x. So if I started with f of negative x and I ended with f of x, that will tell me that it is even. Okay. Same thing here. F of negative x, that's negative x to the 5th plus negative x to the 3rd, which negative x quantity to the 5th is negative x to the 5th, minus x to the 5th, or to the 3rd. So if we say negative x to the 5th minus x to the 3rd, that is the exact opposite of our original function. So this one would be odd. Okay. And this last one here, we have f of minus x equals negative x squared plus negative x. So that is x squared minus x. So it's definitely not the same because of the plus minus, but it's not opposite because both of these are positive, so it is neither. Okay. Now you may have noticed, well, if it's even, my exponent's even. If it's odd, my exponents are odd, and if it's neither, I've got both exponents. That is a good indication of what's going to happen. It won't always work like that. Let's say what happens if we have maybe f of x equals the absolute value of x. Okay, that we just can't look at the power because there is no power. So I'd have to say f of negative x equals the absolute value of negative x. which is x. So in this case, it does tend to be even on this one. This one also has, if we look back here at symmetry, it also has a vertical line of symmetry. Okay, if we look at our absolute value function here, it has a vertical line of symmetry. All right, state the domain range of the function. Often I might just put state the dr, okay, domain slash range. Okay. Well, domain is our x value. So if I look at this x-axis, where does my graph cover it? Well, the lowest it could be is -5. And it starts at -5 and it's still covering all the way up. And I notice I got an arrow here, so it goes on to infinity. Range is my y-axis. So where is this graph covering my y-axis? Well, the lowest it starts is 0. Okay, that y value right there. And the highest it goes, well, if you notice this arrow here, it keeps going up to infinity. So 0 to infinity. Okay. I find the interval when the function is increasing, decreasing, or constant. So that's increasing, decreasing, constant is what I often abbreviate it as. So when is my graph increasing? That means when does the graph have a positive slope? Okay, so from here on, it's got a positive slope. So from 2 to infinity, we have a positive slope. Okay, and it's not increasing anywhere else. Okay, so when is it decreasing? So we'd say it's decreasing from, well, here to here it's decreasing. So it's -5 to -2 union. And then it's decreasing from 0 to 2. Okay, when is it constant? Meaning when does it have a rate of change of 0? Well, right here to here. So that would be -2 to 0. Okay, and I've got all my windows covered. This should cover the entire domain of your function. Okay, my domain went from -5 to infinity. So I go -5 to -2, -2 to 0, 0 to 2, 2 to infinity. So I've gone over everything there. Okay, average rate of change. We talked before that our average rate of change is our slope. Okay, change of y over change of x. Now, change of y over change of x normally finds the slope of a line, which has a constant rate of change. But I want to be able to find the average rate of change of any curve. So we're going to look at change of f of x over change of x. Okay, and I can rewrite that f of x1 minus f of x2 over x1 minus x2. Okay, and I have a picture here that kind of talks a little bit more about that. So if I got 2 points here and here, and I want to find the average rate of change between them, okay, that's the slope of this line. This is called the secant line. Well, that's just your rise over run. So my rise is the difference in your y values or your f of x values. So that's where we get the f of x minus f of x. And you can switch to x1, x2 and over your run. So we're finding the difference between x1 and x2 there. Okay, so this is what we need to know here. So find the average rate of change of f of x equals x to the 4th from, and I'll give you some intervals here. So from -1 to 0. So we're going to look at f of -1 minus f of 0 over -1 minus 0. So to find f of -1, I take -1 and I plug it in here to x. So I have -1 to the 4th power, which is 1, minus f of 0, 0 to the 4th power, that's 0, over -1 minus 0. So that is 1 minus 0 is 1. Negative 1 minus 0 is negative 1. So my average rate of change is 1 over negative 1. So that tells me that the slope, or the average rate of change of my curve, is 1 over negative 1. That means it's decreasing. Now, this doesn't mean that it follows that line. Okay, if we look back up here, this secant line here does not have to follow the curve. It's just telling me on average between this point and this point, it's rising. In this case, it's rising maybe up 1, right 1. Okay, that's what it's telling me on average. So between 0 and 1, so I have f of 0 minus f of 1 over 0 minus 1. So f of 0 is 0 to the 4th, which is 0. F of 1 is 1 to the 4th, that's 1. And 0 minus 1. That's minus 1 over minus 1, which is 1 over 1. So in this case, it's going up, like this one might be going up 1 over 1. Okay. X equals 2 to x equals 1. So I have f of 1 minus f of 2, 1 minus 2. So f of 1 is 1 to the 4th, minus f of 2 is 2 to the 4th, which is 16 over 1 minus 2. So it's minus 15 over minus 1, 15 over 1. Okay, so it's rising at a much faster rate. So I've got this fourth polynomial here. Okay, and if I look at 1, negative 1, and 2, okay, from here to here, between this window and this window, the slopes are similar, they're just opposite directions. Okay, this one's decreasing, this one's increasing. But then from 1 to 2, this line is going much faster. Okay, here to here, we were at this line. Okay, that's much, it's not as steep as this one right here, so it has a different rate of change. Okay. Now I could find the average rate of change of every point on this curve, and that's what we're going to look at now. Okay. We have what's called the difference quotient. And the difference quotient helps us find the average rate of change anywhere on a curve, given two items. We have an x and an h. Okay, x is your starting point, and h is the distance between your start and end. Okay, so like on this one here, we had a starting point of 1, and the distance between my starting point and my stopping point was also 1. So I'd say h equals 1. Now, let's show that this is actually the rate of change. We had the rate of change was f of x, we'll say x2 minus f of x1 over x2 minus x1. Okay. Now, h is the distance between the two. Okay, so if I say x2 minus x1, that gives me what h is. Okay, so right here I can say that this whole thing is h. Okay, from this right here, it's the difference in your starting and stopping point. So if I now solve it for x2, I get x2 equals, just add this to the other side, x1 plus h. Okay. Well, I'm just able to get rid of these now because I have them in both terms. I could say f of x1 plus h minus f of x1. Since they are both in terms of x1, I don't need to put the subscript 1. Okay, that's not necessary. So this is f of x plus h minus f of x over h. So we start with the average rate of change, and we have out the difference quotient. Calculate the difference quotient for the function. Okay, well, the difference quotient is f of x plus h minus f of x over h. So to find f of x plus h, we're going to take x plus h and just plug it right in here to f. So I have 2x plus h squared plus 1. That covers this first portion, minus f of x. F of x equals that whole thing. So 2x squared plus 1 over h. So then I'll FOIL this. So I have 2x squared plus 2xh plus h squared. Again, that's square the first, multiply them together, square the last, plus 1 minus 2x squared minus 1 over h. So then we'll distribute my 2, get 2x squared plus 4xh plus 2h squared plus 1 minus 2x squared minus 1 all over h. So now I get to combine like terms. So I have x squared minus x squared plus 1 minus 1. And I have h, and h. So we'll get rid of this one, and one of those. So then I have 4x plus 2h. And that will find the average rate of change anywhere on this curve. For example, if I want to look at what's the average rate of change in x equals 1 to 3, okay, that would be f of x, or f of 1 minus f of 3 over 1 minus 3. Well, to find f of 1, I put 1 in up here. So 1 squared is 1 times 2 is 2 plus 1 is 3. 3 squared is 9 times 2 is 18 plus 1 is 19 over 1 minus 3 is minus 2. So 3 minus 19 is negative 16 over negative 2 is 8. Well, I can get that same answer using this right here. But in this case, my starting point, which is x, is 1. My h, which is the distance between start and stop, is 2. Okay, so I have 4 times 1 plus 2 times 2. Well, that's 4 plus 4, which is 8. So this helps us to discuss the average rate of change anywhere on my curve. Okay, this is actually called your derivative, okay, which you'll talk about more in calculus. Okay, graph, state domain and range, and intervals for increasing, decreasing, and constants. So these are piecewise functions. Okay, they are very, very easy to graph. Okay, you have to understand that you have in this case, 3 different parts of this graph. Okay, and this separates your 3 different parts. Okay, so if I graph this out here, and we'll just kind of sketch a graph here. Okay, so I have a window, or a couple windows here. I have a window from x less than 1, minus 1. So I have a window to the left of that, between negative 1 and 1. So I have a window in there, and I have a window bigger than 1, so from here on. Okay. So now we want to take this by part, okay? So from when x is less than negative 1, I have an x squared. So I've got some points here in this window that I'm just going to plug in. So if x is negative 1, Okay, negative 1 squared is 1. So I'm at negative 1, 1. But I can't actually choose it because it's not equal to, so I'll put an open circle there. Okay, then I'll plug in negative 2. Negative 2 squared is 4. 1, 2, 3, 4. Negative 3 squared is 9, so we're way up here. Okay, and that's that curve. Okay. From negative 1 to 1, between here and here, we're at 1. So no matter what number is in here, we're at 1. So that includes this one all the way over to here. And that includes that one. Okay, that's a closed circle. So if I plug in negative 1, I'm at 1. If I plug in 0, I'm at 1. If I plug in 1, I'm at 1. Doesn't matter. Now we've got x greater than 1. Okay, so from here over, we have x. This is the equation that I use. So I'll plug in 1. At 1, I'm at 1. So I've got an open circle because it cannot equal it. At 2, I have 2. At 3, I have 3. 4, I have 4, and so on. So I've got that portion right there. So here I have a linear, I have a constant, and I have a quadratic. Okay, so here is my graph, a piecewise function. Now, state, domain, and range. So domain, range. The domain is what x can be. Anything here, anything here, anything. Okay, it keeps covering infinity that way, and it'll keep covering infinity this way. So that is negative infinity to infinity. Your range. Well, what is the smallest y value that I could have? Well, I notice it doesn't go below the y-axis at 1. So I've got 1 to infinity, and it starts here and goes up. Increasing, decreasing, and constant. Okay. Where is my graph increasing? Well, it's increasing from 1 to infinity. So 1 to infinity. Where is it decreasing? Well, it has a negative slope right here, this portion. Now, even though this arrow is going, oh, you can't see. Even though this arrow is going up, we read it left to right. So it is decreasing from negative infinity to minus 1. And where is it constant? Right here. It's a constant slope right there. So negative 1 to 1. Now notice that follows my domain, negative infinity to infinity. And negative infinity to minus 1 to 1, 1 to infinity. So I've covered everything. Now, we can put these on a graphing calculator to help check our answers. Okay, so if I do this here, we'll go to y equals, and we will say parentheses x squared, parentheses x. We gotta find our, here we are, x less than minus 1 plus 1, and then we gotta input this interval. So negative 1 less than equal to x less than equal to 1. Now to get these inequality symbols, I'm hitting second math to get this test. Plus x greater than 1. Okay, and we should have all of our lines on there. And if I graph it on this same kind of coordinate I have for that one, so we'll say negative 4, 4, and negative 5, 5. So you can kind of see what you can kind of see what's going on. Okay. Now, I don't know what happened right here and right here. And then we could even go ahead and input some values here. So at -1, I'm at 1, and we can check some things on that. Okay, so let's graph this one. Okay, so I've got 3 of them here. So these are my ranges. So I like to kind of graph out what's going on here. 1, 2, 3, 4, 5. I like to put my intervals on my graph. Kind of helps me keep organized just a little bit. So 0 is kind of my changing point, and 2 is a changing point. Okay, so I'm going to know what's happening less than 0. Okay, so at 0, if I plug in 0 here, I get 1 minus 0, so that's 1. But I have an open circle because it's not equal to. So I'll plug in -1. 1 minus -1, 2. Plug in -2. 1 minus -2, 3. 1 minus -3, 4. And you can probably see the pattern from there. Okay, it's a line going that way. So from 0 to 2, we'll plug in 0 and I get x. So that's 0. Which I can include it, so that's a solid circle. I get 1, 1, and I get 2, 2. You got that line right there. I also know it's linear because there's no exponent there. When x is greater than 2, I have -1. So 2, I'm at -1, open circle. And anywhere greater, I'm at -1. So I'm right here. Okay. So again, what's the domain? Domain is -infinity to infinity. There's no x values that I got to cancel out. What's my range? Well, the smallest y value I can have is -1. But if you notice, I can't have anything in here. Okay, so I got to get rid of that. So the smallest y value I can have is -1. So we'll say, okay, I've got 0 to infinity is a window. Okay, so that's that part. And I got to get this 1 in there. So union, we say -1. I think that's how they want you to recognize it. Yeah, that's how they want you to do it. That's the set notation on that one. So increasing, decreasing, and constant. So where are we increasing? We're increasing right here from 0 to 2. We're decreasing from -infinity to 0, and we're constant from 2 to infinity. And you might put, well, that's a parenthesis maybe there because it's an open circle. Increasing would be bracket there, or parenthesis there, and then I got brackets on that one. Again, we could graph this on my graphing calculator to double check. Okay, so here's our suggested problems. 83 is a great challenge / word problem that you need to look at. If you got questions, you can always come in and get some extra help. And as always, this is at THS Mr. Jones signing off. Be sure to subscribe and like.